Okay, hello guys, welcome to Crown Smart. In this video, we wanted to be talking about sigma algebras. Now, sigma algebra, what is a sigma algebra? So, sigma algebra is just like an algebra, but it's also a class, okay? So, a class, a class, so this is a class of subsets of R is called a sigma algebra if and only if it satisfies the three conditions. Now, what are the three conditions? That the empty set must be in this sigma algebra, in this class. If E is an element in this sigma algebra, this implies that E complement is also what in this sigma algebra, and given a sequence of n equal to 1 to infinity subsets of this class, this implies that the countable union of this sequence of en is also in what? This. So observe that this just looks like an algebra. The only difference here is that this is no longer a finite union, but a countable union is a subset. This time around, the countable union, which is a subset of this, implies that the countable sequence, which is a subset of this, implies that the countable union is in what? Is in this sigma algebra. Now, we also have a proposition. So this is just a definition of a sigma algebra. Now we have a proposition. Now the proposition says that every sigma algebra is an algebra. Every sigma algebra is an what? Algebra. So let's write down the proposition. Okay. So proposition. Every sigma algebra. Every sigma algebra is an algebra. Every sigma algebra is what? An algebra. Proof. Let's prove this. Now this is a very interesting proof. Okay, we're gonna do it. It's just an interesting proof. Now, of course, now the proof here is that we want to show that every sigma algebra is what? An algebra. Observe that the converse is not true. So not every algebra is what? A sigma algebra. So the converse is not actually true. But every sigma algebra is definitely what? An algebra. So we want to prove this. Now, to prove this, we have to show that it satisfies the condition of it. We have to show that this sigma algebra satisfies the condition of being what? An algebra. So that is to show that every sigma algebra is what? An algebra. So we say let this be a sigma algebra. We say let this be a sigma algebra. First of all, let this be what? A sigma algebra. Now, if we let it to be a sigma algebra, we show that our job, we show that this is an algebra. And of course, for this to be a sigma algebra, it means it must satisfy these three conditions. Okay, so for it to be a sigma algebra, of course, this condition is already met. That is, this condition are satisfied already. So when we say let this be a sigma algebra, it means that for this to be a sigma algebra, that it has already satisfied, this condition is already true. Now we want to show that this is an algebra, meaning that we want to show that, for us to show that it's an algebra, the hint here, for us to show that it's an algebra, that means we show that the empty set, the hint here is to show that the empty set is in what? Is in this. that if E is in if A, let me take A. If A is in this fancy A, then this implies that A complement is in what? The fancy A, right? And also, if A B is in this fancy A, then this implies that the finite union A union B is also in this what? Fancy A. Okay? Now watch. Observe that the first two conditions are already met. That the first two conditions are already trivial. You can already see it from the definitions that it being a sigma algebra is just the same thing as it being an algebra for the first two conditions. So for us to show that every sigma algebra is an algebra, it suffices us to show the third condition. What is the third condition? We need to show that if you pick any two sets in this, then the finite union is in this. So if you want to show that something is every sigma algebra is an algebra, you just have to show the third property. Showing the third property will help us conclude the fact that this is what? An algebra. So let's make a construction. So since this is a sigma algebra, it means that since this is a sigma algebra, we say let the sequence n equal to 1 to infinity be a subset of this fancy A. So this implies that the countable union n equal to 1 to infinity of En is an element, not a subset. It's an element of this sigma algebra. Now the reason is because this is a sigma algebra. So this is actually true. Because it's a sigma algebra, this third condition is true. Now we want to show that this is an algebra. So now I will now say, let's make a construction. Let E1 equal to A and let E2 equal to B and let En equal to empty for n greater than or equal to what? 3. Okay, so we take the first part. When n is 1, we call it A. When n is 2, we call it B. And when n is 3 or above 3, that is when n is greater than or equal to 3, we call it what? Empty. But since this is a sigma algebra, the countable union is in is in A, right? So we have that the union n equal to 1 to infinity of En is in what? A. Okay, so this implies that the union n equal to 1 to infinity, okay, not this implies, but the union of En, but the union of this is this is actually the union E1 union E2 union the union of n equal to 3 to infinity, okay, of En. Okay, now of course this is what this will give us: E1 union E2 union the union of En, where n is running from 3 to what? Infinity. Now what is E1? So this is equal to, what is our E1? Our E1 is A union B union. Now what is our En? Our En is the empty set, so this becomes the union n equal to 3 to infinity of what? Empty. And of course union of empty set is what? Empty. So this is what? A union B union what? Empty. And of course A union B is A union B, then the result union empty will still give us what? A union B. So we have shown that this is actually what? A union B. And what, since this is in A, this implies that A union B is in what? Is in this fancy A. Sorry, this is not actually A, this is fancy A. Okay, so we have shown that A union B is in A. So we have shown the third condition. The third condition that is that if AB is in A, this implies that the A union B is in what? This fancy A. So hence we have shown that every sigma algebra is an algebra. But remember, the converse is not what's true. So not every algebra is what? A sigma algebra. We'll do that in our next video or tutorial. Thank you. Please don't forget to subscribe, don't forget to like, and don't forget to share to your friends. Thank you.